So the question then became, okay, we can put in 1 million tokens. Does it work for 1 million tokens? And that's a very different thing because the model providers, the labs, they release these needle in a haystack benchmark results, right?
Yeah.
And every section we have 100% retrieval. But yeah, if you're a data scientist, you know that anything that scores 100% is very suspicious.
So welcome everybody to the AI Rapid Roundtable, where we bring together builders, researchers, and operators to unpack challenges at the frontier of AI. I'm Javier Rincon, and co-hosting is Adrián Tineo. Together, we run 42 Automation, an agency that builds agentic AI systems with a focus on Evals. Adrián, do you want to say hello?
Of course, it's great to be here, and let's unpack a lot of good stuff today.
Very good. And joining us today is Bauke Brenninkmeijer, AI engineer at Orq.ai and Lead at the MLOps Community in Amsterdam. Hi, Bauke.
Hi guys, very happy to be here.
Excellent. So before we jump in, maybe you could tell us shortly a little bit about what you're doing at Orq.ai.
Yeah, for sure. So I only joined 2 months ago, but it's been a tumultuous 2 months. But my role here is mainly to research technologies and see how we can implement them in our platform. And our platform is an or an LLM ops and observability platform. So it allows you to do the tracing, and then we have a lot of tooling around that to do automated evaluations, to run experiments on data sets that you've created with things that have happened with your chatbot. And so my role here is, yeah, looking at the latest research, looking at tools that are coming out. Is there a place to use these within the platform? And also, I think because we have such a practical orientation, there's a lot of things unresearched within this domain. So there's a lot of open questions, and also how does it apply to our clients, where it might work in an academic benchmark, but we need to understand how to communicate it to our clients as well.
Very cool. Very cool. Excellent. So let's jump into some topics. So we've got 5 topics today. So we'll try to cover all of them, maybe 5 minutes at each. So yeah, Bauke, you've had quite a month recently. 2 conferences, 2 talks, 1 panel, all centered around your experiment on RAG versus long context LLMs, based on Chroma's study on context RUT also. We've ourselves have been working on this topic deeply, so we're very excited to go deeper together with you today. So you started with one question. When should teams still rely on RAG given its flaws, and when shouldn't they? So after burning through 300 million tokens, you finally found some patterns. So let's start by talking about your goal and findings on the limitations of RAG for long context.
Yeah, for sure. So it all started from a point of just trying to implement a reliable RAG system that we were building. And we had this use case for analyzing sustainability documents related to companies. So this can be annual reports or sustainability reports. And then the questions would be, okay, what are scope 1 emissions of this company? What was the CO2 emissions of this company in this specific year? And this was in the period that Gemini 1.5 Pro had just come out. So it's still pretty good model, even though it's not state of the art anymore. But that model also had a context window of 2 million. And during our testing, we realized a couple of things. One, the ground truth for this data is inherently vague and unclear. The terms are not defined very well yet, because the regulation is not that old. People report it differently between different companies, different sectors, and sometimes they don't report it at all. And then in addition to that, we have the trying to scope it in time, which is with RAG very hard, because it might get a chunk that says, okay, there was this much CO2 emissions, but then maybe you don't have a year for that chunk because it's not mentioned in the chunk, and maybe it's not mentioned in the file name. So and this is just one dimension. Obviously, it could be in all types of different dimensions that you want to analyze specific questions, and that becomes very challenging with RAG. So our understanding was that RAG was in essence just not going to cut it, and unfortunately we didn't get to continue with the project to figure out if the full context option would have been interesting. But that's a question that primed me for a couple months, like, okay, this is definitely still interesting, and so many people are using RAG that that are also working with these long context models. So for so many people, this is a relevant question. And so to put it in perspective, the context window of the current, most of the current state-of-the-art models, which is 1 million tokens, that allows you to put in several thousands of pages of documents. So yeah, incredibly much. And in these types of constrained retrieval tasks, that's typically enough depending on use cases. But if you're talking about RAG chunks, that is, I don't know, it might be millions of chunks. It's really a lot of context. Yeah, so the question then became, okay, we can put in 1 million tokens. Does it work for 1 million tokens? And that's a very different thing because the model providers, the labs, they release these needle in a haystack benchmark results, right?
Yeah.
And every section we have 100% retrieval. But yeah, if you're a data scientist, you know that anything that scores 100% is very suspicious. And so the same goes for this benchmark. So either the benchmark is too easy or you know, in some other way it's flawed, but it definitely, if you've used an LLM for more than 5 minutes, you know that it's not 100% because you see it failing when the context gets longer. So that's where the research of Chroma was super interesting, and it was very interesting to hear you guys also back up these findings in a, you know, similar ballpark to see exactly where LLMs really start to fail and under which conditions.
Yeah, this is great, and we can relate to that 100%. So if we take a step back for a second and we think about the needs of processing large amounts of documents, and we have this incredible technology of large language models, so it becomes only natural that we start thinking, how can we process in long documents or many, many millions of documents? And then there is a promise from the Frontier Labs on one side, which is don't worry about that. We're going to keep increasing the context window and look at these benchmarks. This is all amazing. And it's like, whoa, where you can just throw anything and the model will solve it. And then, but the interesting thing, and we see that time and time again in our analysis, is that the real world is very messy. And I think that's both the beauty and the challenge of natural language. Natural language is so expressive, you can communicate almost anything you want, but at the same time, it's very difficult to create a repeatable, solid structure. And that's going to lead to failure points from these models. So the question is, okay, so we have this technology, it goes maybe 80% of the way, but 80% of the way is not going to cut it for enterprise or for, you know, a lot of use cases. So how do we go the extra mile and what is available to us? And I think that takes us also to this conversation about, okay, RAG is kind of a first approach. It does a lot. Let's not deny that. But again, it doesn't go all the way to the quality that we need. And then what comes next, right, Javier?
Absolutely, right? So the next frontier after RAG, right? So, we've talked about retrieval, a long context, and how they have their limits and how they might complement each other. So the question is, what does come after RAG? So we're seeing a lot of attention now shift towards reasoning loops and agents, systems that don't just retrieve, but actually iterate, reflect, decide to do next, what to do next. So here's the big question. Are reasoning loops the missing ingredient to fix long context reliability? Will retrieval eventually be absorbed by models or orchestrated by agents? How do you guys see that?
So my perspective, and you know, take into consideration I'm not working at a research lab, but if I would have to speculate, I think it will move into a direction where different parts of the technologies become more mature, and as a whole, they start to resolve this problem more structurally. I don't expect, right? We've seen the recent model slowdowns in intelligence. The scaling has kind of flattened or gone down even. So I don't expect a miracle there. Like there's been research on, you know, infinite attention mechanisms, but also just practically from a hardware perspective, that's yeah, well, we will never reach infinite, right? Maybe we will go a bit higher, but there's definitely a limitation there. So the so something that I think ties a little bit into this into the agentic loop and the performance there is, for example, in my post and also my talk, I had quite a long rant about Cloud Code and what it could do and what it couldn't do. And I think that's at least, you know, my main experience with agentic loops. But over the last 2 months, and obviously there was Sonnet 4.5, that loop has become significantly better, like noticeably better with a small model upgrade. And that can be scaffolding, that can be model training, and it can be error correction from the model, like realizing it's made a mistake and then recovering gracefully from that. And I think many of those behavioral differences will trickle down into these retrieval use cases where an agent might do a retrieval, it might understand, okay, I don't have the right answer, I don't have enough context to answer this properly, I will keep looking. And you get into a situation where you have an autonomous research retrieval agent that kind of goes off and solves this. And agentic RAG has been a thing for a little while now. I think in the beginning it was still quite brittle, but as we move to a situation where these models are able to do in somewhat close domains be very effective, I think that will become a much more reliable source of information.
Yeah, definitely. And if we think about uh, the breakthrough of the reasoning models, right, with the reinforcement learning conditioning, I think there's a parallel with the long context. So if we take the model as a monolithic block, and then we thought about, okay, we need to process long documents, let's just make the context window larger. And now we're thinking, okay, we realize that reasoning is actually very helpful, and the model improves when it goes over and over the piece of work. Then okay, let's build that into the model, which is what the thinking models do. And that works to a certain extent. But again, it has some limitations. And I think it's very important for builders everywhere to have the leverage to configure the system beyond that. And that's where I think it becomes into the agentic aspect and the loops. And it opens the door to smaller models, as you were saying, right? Because then you might also configure or optimized for a particular use case or particular domain, and you might have smaller models which are also faster and have better governance features. And that also goes into the same paradigm of having the model cook for a while over the response before arriving to a conclusion. And there was this comment from Jan LeCun, and he would say, models today, they just produce one token after the other, and the cost of producing one token is fixed, but not all questions require the same level of intelligence. So how do we actually make the model work harder for harder questions? The way we have today is to make it produce more tokens and maybe do self-consistency check and similar things. But it seems obvious that if we have a more complicated, more nuanced, more elaborate problem, we need a way for the system to cook for longer. And there are multiple ways we can do that. And I'm really excited that the agentic patterns are starting to emerge and opening up the possibilities for builders everywhere. And now the next question would be like, okay, so we have these systems, now they can generate answers, but can we still say they are the good answers, or how do we do that, right?
Absolutely. Yeah, and I mean, I'm incredibly excited about agentic AI going in that direction, but I'm also, very passionate about the next topic. So we've talked about the evolution of systems from retrieval to reasoning, and the next question is, so how do we actually know what works, right? So, everyone says evals matter, that you should be focusing on them. There's content everywhere around it, but hardly anyone is really running them or running them effectively, right? So the thing is, evals are what turn AI experiments into systems you can trust. They're the feedback loop that tells you if your latest prompt model or retrieval setup actually make things better or worse. So without evals, you're really flying blind. And so with them, you can prove impact, fewer hallucinations, better reasoning, faster responses. So why aren't teams doing this yet at, effectively or at scale? Is it a tooling gap? Is it too hard to integrate? Is it a culture gap where people still treat evals like research and not production? What are your guys' thoughts?
So what I've seen here is, I think, two things. One is definitely a maturity gap. Many clients are just really not there. They barely have the operational system in place, but then the observability and evaluation steps are still, they're not at a point where they realize that they need it. And before they, consider something like that, they need to feel the pain that the absence is causing. The second one is, I think, definitely tooling is also becoming mature. There's quite a lot of platforms now that offer tooling on a more platform level, like we do, and also Langsmith and Arise. And then you also have more SDK based or programming based evaluations. I think was a Deep Eval is one that provides a lot of them, but there's many of them that offer some shape or form of evals. The issue with evals is I think also they're not homogeneous. So there is programming evals. There can be more classic NLP evals, such as Rouge and Blue scores. And then obviously the most recent one is LLMs as a judge, which they're also quite flexible because I can create an LLM as a judge with a certain prompt, but then you might feel, oh, wait, but this doesn't consider all my specific business needs or my specific use case needs. So I want to update the prompt. Often when you're working with an SDK, those things are abstracted away for you because otherwise they don't provide any value, right? It's a wrapper around a prompt that is easy to execute on your data. So if you need to update those things, it's not rocket science to run a prompt with context on your data. So then the added value of the framework kind of goes away. So we're in this weird situation where I think the added value is not enough to warrant most integrations or adoptions of platforms. But people also don't have a good understanding of what is needed for them to do it without those. So one thing that we've been working on is also to propose kind of groups of evaluations that are very specific to use cases, but a very good starting point to get started. So one is for agents, obviously, like you can evaluate agents in a billion different ways, more behaviorally or factually, or there's all these different dimensions to look at. And so we've created kind of a set of 10, which we think gives a very good initial insight into how your agent is doing. And then if you have some data set and you run these on them, and then you can go from there, you at least have a good baseline, and then you can be like, oh, but for my business, I also need this specific thing, and I also need this specific thing. You can add them accordingly or update prompts as needed for your use case.
Mm-hmm.
So yeah, I think that kind of covered it.
Yeah. So I think you're spot on with the maturity gap, and the way I like to think about it is like back in this regular software engineering years, we would have unit testing, right? And a lot of teams would ship without unit testing. That's unheard of these days, but it used to be like that the day. And I think we are in that part of the curve now with AI applications that we are shipping stuff and see how it works in the wild, but we don't really have a plan for making sure that it's actually doing what it needs to do. I wanted to touch on the LLM as judge, which, as you mentioned, is very common these days to start doing some evals. Maybe address a misconception which is common, which is now everybody can prompt, right? And that's actually what's leading the conversation around work disruption and layoffs and whatnot, because hey, if anybody can prompt, then whatever job can be automated. And now by that token, you would say, hey, we need evals. Of course, we can use LLM as judge, and then we can just ask the LLM to fix itself. And then what we find is that, okay, there's a lot of nuance and there's a lot of things to consider there. So even though there's definitely a good tool to use LLM as judge, it needs to be done with based on first principles. So I think that's where it pays off to do the groundwork of understanding the application, understanding what's important to evaluate, understanding what is a good response versus a not so good response, in what dimensions. There's a lot of to unpack there, and it's a good start, to throwing an LLM as judge. But as we mature, I expect that we get a lot more, a lot deeper into that.
Absolutely. And of course, this is all work in progress. We're all in the starting days here, right? And it just brings me to the next element, in terms of context engineering. So we talked about retrieval, reasoning, evals, and there is a quiet layer underneath all of it, right? And that's context engineering. So how you shape context, what data goes in, how it's structured, how business rules get embedded. it's quickly becoming maybe the new business logic of AI systems. So here's the question: has business logic shifted to the context engineering layer, or will this soon be plug and play, handled automatically by the models themselves? So how do you guys see context engineering evolving?
Yeah, so for me, I think there's two dimensions to context engineering, which is one, determining which parts are actually deterministic within the application, and then the second one is the anthropic context engineering logic or intelligence, which is a very different part. I think I want to touch upon the first one first because it's so fundamental, and it's something that a lot of people I see get wrong, where they give a lot of the business logic to the agent and then expect the agent to flawlessly execute that. And then the reality turns out that agents are often not flawlessly executing on that. And often you see that there are components in there which are deterministic, right? So retrieve the client information. We were doing a POC with the airline. So you had to retrieve the client information and then the booking information and then the flight information. And all of that needs to happen every time in the same order. So there's absolutely no need to do that with an agentic system, even though that would be constituted as business rules. So understand what needs to be in the agent and understand what definitely doesn't need to be in the agent. And then you can get those results deterministically, inject them into the context, because you do likely need it later for steps that are non-deterministic, but that will increase the reliability. It allows you to omit tokens and operations from the context window. So yeah, it saves a lot of headache. And then the second one, which I think is super interesting, but also very new, and I don't think anybody has any idea how to do it, but that is the more dynamic content engineering, where you're like, okay, this was for a previous operation, so we just exclude all of those assistant messages and all of those user messages because it's not relevant anymore for what we're doing, and we're dynamically maybe compressing certain parts of the context, but we have the previous context somewhere stored, which we can retrieve if needed, and plug it into the context again. Yeah, you have your blank canvas of 200,000 tokens, and kind of what do you put in there and what do you not put in there, is a very interesting direction. And yeah, I don't know enough about it to comment on the internals or where we are right now or what will be the next step. But I think some intelligence that will do this selection more dynamically will play a role there. Maybe that will be a different model because you don't want to wait for a second model that is like dynamically assessing, do I still need this? Do I not still need this? But I'm very curious where that will go, and that will, without changing too much in how we train the models and needing to increase to 1 million, 2 million, whatever, it will allow us to effectively use the available token size or the context window size way more effectively.
Oh, yeah. A lot to unpack there. Maybe just a quick comment because I know we're getting close to the finish line here. So it's like there used to be this concept of the ChatGPT wrapper. Like at the beginning, all AI solutions, everybody said, "Oh, it's just the ChatGPT wrapper," kind of a lower level solution. And then as we mature, we realize there's a lot of into making the right request to the model, the right query with the right context, with the right information, what is really needed, how to maximize the chances of success. And it turns out that's maybe what is eating away the business logic layer, as Javier was mentioning before. So just maybe shedding a little bit of appreciation for that new art that we're starting to learn about context engineering.
Absolutely, yeah, fully aligned with both of you guys there. And ultimately, the last element that only matters kind of is really customer trust, right? We're just building towards gaining that customer trust. So what actually builds that trust? Is it better retrieval, smarter agents, solid evals? Yes, but how important is it to design for failure? To have clear fallbacks, UX patterns that gracefully handle when AI gets wrong. So what do you think drives customer trust at the user level, and what's important to keep it?
Yeah, excellent question. I feel that a lot of people, when they are starting out, they trust the system, regardless of whether they should trust it. So everyone starts out trusting their AI system, And then when they go one step further and they realize, wait, it's failing in all these situations, and they lose the trust, and then you have to get it back and go back to fundamentals, which are, some metrics, some data set that you have looked at with your own eyes and understood, okay, how is it failing when it is failing? I think those steps are fundamental. And then once you understand how to do it statically or offline with the evaluations, and then you can apply it to an online situation, and your agent, is doing this is correctly, and maybe my evals are not picking up on these specific things still. Then you start to have trust in a system again. But yeah, you need to kind of go through the learning curve there yourself.
Yeah, I think the key aspect about trust is that it's a game for everybody. So everybody is into producing that trust, and I don't know if that's generally understood in that way. So it looks like it's a maybe engineering problem. So the engineers need to solve it, or it's a frontier lab responsibility. And I actually think it goes across the chain in every role. So what does it mean to do a good introspection about what is the problem we're trying to solve? How do we advocate? How are we the champions for the customer, and really address the problems, and also at the same time be fair and transparent about where the model or the system might need some work.
Absolutely, guys. Well, really fascinating chat. Just to close off the conversation, I want to just take us into the rapid three. So just three very quick questions. Maybe you can answer them with a sentence or two rapidly. So I'll pass this for Bauke. So first of all, what is your top best practice teams should follow to be successful, in an AI implementation?
Sorry, my top what practice?
Your best practice. So what should be
Best.
your top best practice you should follow to be successful with an AI implementation?
Start small with realistic data, and it will become so obvious so fast where the system is failing, and you'll feel stupid about not thinking about those edge cases before.
Amazing, amazing. What's one mistake you see AI teams make again and again?
Oh, yeah, not validating enough. I think that's it. They have operational systems, but no evaluation systems.
Great. And lastly, if an agent could replace one task for you tomorrow, which would it be?
Uh, um, Managing all my different Git work trees. I always got lost in all the different ones I'm using.
Very nice. So let's hope that comes around faster than later. So guys, thank you so much for coming to the AI Rapid Roundtable. Bauke, thank you so much for your participation. Guys, if you're in Amsterdam, make sure to check out the MLOps community. They have amazing events going on there with incredible people. So thank you to Adrian too, and see you in the next AI Rapid Roundtable. Bye everybody.
Thanks, guys.